So, section 2.5 we're actually going to do over the course of 2 days. So we're going to do all the definitions today, and then we're going to look at the 2 postulates that we learned today. And then tomorrow when you come in, we're just going to pick up right where we left off with proofs. So there won't be a new warm-up, there won't be a new section number or an objective or anything like that. The last example we do today, we'll just go right into tomorrow's example when you walk in. Which is nice because we do have a short day tomorrow, so that'll kind of make up for those few minutes that we missed. So today what we're going to look at is to show triangles are congruent using SSS and SAS. Ooh, there's no section title, is there? Alright, I'm going to add a title for you. Here's the title. SSS SAS. I'll just put and. Like they're going to battle it out. So, sorry, I don't know where that went wrong in this PowerPoint production. But yes, our title is SSS and SAS. Alright, here's your vocabulary words. These will actually cover today and tomorrow, so it looks like a lot, but it's 2 days worth of vocabulary. So the first vocab word is proof, and then you'll just have the 2 postulates. There is a very important part that needs to be emphasized in that second postulate, and it is this, the included angle. So underline that as you're writing these. So I'll give you a couple minutes and then we'll discuss these. So the vocabulary word for today is proof. This is what we're going to cover tomorrow. A proof is a convincing argument that shows why a statement is true. So tomorrow I'm going to give you some information and I'm going to basically say, here's what's true. Tell me how you know that it's true. And you're going to argue why that particular statement is true based on the information that you're given. But like I said, we're not getting there till tomorrow. What we're going to focus on today are the 2 postulates that are on the board, the side congruence postulate and the side angle side congruence postulate. So yesterday we talked about the idea of congruent triangles. Congruent triangles have all 6 corresponding parts congruent. So one way to say that 2 triangles are congruent is to prove that the 3 angles are congruent and that the 3 sides are congruent. That's a lot of extra work. It's actually not necessary to prove that all 6 of them are congruent. You could actually just prove certain combinations are congruent, and that forces the triangles to be congruent. So here are 2 of the combinations we're going to look at today. Side, side, side. So if you can prove that all the sides are congruent in the 2 triangles, the triangles must be congruent. And then the other one is side, angle, side. So if you have 2 triangles, and you have a side, the angle in between those 2 sides, and the other side congruent to the corresponding parts in your second triangle, then those triangles are congruent. It sounds like a lot. We're going to look at some examples as a class before you have to write any more in your notes, so there will be some more time if you have questions on those. The nice thing about doing section 5.2 over the course of 2 days is that you can also have a chance to ask questions on your homework tomorrow before we start the second half of the lesson. So again, if you're a little confused on these as we're going along, you do have 2 days to sort of get it under control. Do you guys have any questions so far? Okay, you do not need to write these down. I just want to look at a few examples before you're required to write them in your notes, just to explain a little bit more about what this means. So, the directions here say, does the diagram give enough information to use the side, side, side congruence postulate? I am not requiring you to explain your answer. I think the answers are pretty obvious, why and why not, so you can just forget about that part. So basically they're asking you, can you say that 3 sides of one triangle are congruent to 3 sides of the other triangle? So on the first set, do you know a side that corresponds with BC in the other triangle? Is there one that matches BC in this other these are the two. So is there one in the bottom triangle that matches with BC? Yeah, do you see how these two are congruent? Okay, so they're corresponding sides and they're congruent. So we have one pair of sides that match. Is there a side that matches with AB? Yeah, AD. Do you see how they both have the same marks, so we know that they're congruent? Now here's where it gets a little tricky. Is there a side that matches with AC in the second triangle? It's the same segment, right? AC is AC, so they must have the same measurement, right? So I've shown, or I can observe that these two sides are congruent, these two sides are congruent, and then AC is the same thing as itself. So do I know that the three sides in the first triangle are congruent to three sides in the second triangle? Yes. So this would be a yes. The side, side, side postulate works here. Now look at the next one. Do I have a side that matches up with EF? Yeah, JL, right? Do I have a side that matches with EG? Yep, this guy. Now, do the third sides match? Is there any indication that they are congruent? Do you see anything that labels them as congruent? They look congruent, but do I know for sure? No. There's nothing that leads me to believe that these two are congruent. So this one is a no. I know that two sides are congruent, but you need all three in order to use the side, side, side. Any questions on this? Alright, I do want you to put these next two in your notes. So go ahead and draw the triangles for both. Make sure that you're labeling them exactly as they are on the board. Those markings, those tick marks that show congruence, those do matter a whole lot in this. They're actually going to change the answer if they're not labeled correctly. So go ahead and write these. Again, you can ignore the part of the directions that says explain your reasoning. It's not necessary. All right, I'll give you a hint. One's a yes and one's a no. Do you guys know which is which? Second one is a what?
Yes.
Right. The second one is the yes. This one's a no. And the reason is, on the first one, I know that AB is congruent to DB. BC, it's the same segment, so it's obviously has the same measure. But we don't know anything about the third sides of the triangles. So this is a no. We have side, side, wah, wah, no side. Okay? But over here, these two sides match up. These two sides match up. These two sides match up. So all three of the corresponding sides are congruent. So that is a perfect example of the side, side, side postulate. Do you guys have any questions? Here's some more information that you don't really need in your notes, but it is something that we need to talk about. So this is all about the included angle. So if you have a triangle like this that we're trying to match up with another triangle, if you know that AC has a corresponding partner in the other triangle, and CB has a corresponding partner in the other triangle, the angle has to be in between the two sides that you're given, okay? That's why we call it side angle side. Okay? So just be careful. It has to be the angle that's in between the two sides in order to use the postulate side, angle, side. Okay? You do not need to write this. No. There are a few on your homework where it'll give you a triangle and it says what's the included angle. So if I said what's the included angle between AC and CB, you're just looking for the angle that's made up from those two segments. Okay, so we call that the included angle. Any questions on the idea of included angle? Alright, here's two more triangles. You don't need to write these either. You can just soak this all in and then we'll do some examples on the next slide together. This says, does the diagram give enough information to use the side, angle, side, congruence postulate? So first let's see what matches, what has corresponding parts. And then we'll see if it matches the side, angle, side idea. So V goes with what? Z. So we have two angles that are corresponding and they're congruent, so that's good. ZY goes with which one? VW, good. And then you can see XW and XY go together. So let's talk about this. Is V the angle between the sides that you know are congruent? What do you think? Do these two sides make up angle V? No, they make up angle what? Angle W, right? This side and this side make up angle W. So the included angle would be angle W. We don't know anything about angle W. What we have here is angle, side, side. Angle, side, side. Does that look like a legitimate postulate? ASS.
Angle, side, side. No. It's supposed to be side, angle, side.
Right, it's supposed to be side, angle, side. The way I always remember this, what is this? You can say it.
Angle, side, side.
It's the only day you can say a bad word in geometry. Okay, there is no ass postulate in geometry. There are no bad words in geometry class. So if you're trying to line them up and you're getting an answer ASS, or if your ass is backwards, SSA, there are no bad words in geometry, okay? So if either one of these is your answer, you cannot say the triangles are congruent. The angle has to be in the middle.
So ass is a bad word in class.
Ass is a bad word in class. If you write it on your homework, I'll mark it wrong. And then I'll put soap in your mouth. No, I won't put soap in your mouth. But just remember, there are no bad words in geometry. So if you're coming up with an answer that's ASS or SSA, you did something wrong, okay? The one that has to be congruent is the angle in between the sides that you know. So if we were going to use side, angle, side, we'd have to know that W and Y were congruent. All right? And again, we're going to spend a few days practicing this, so if you're feeling overwhelmed, just relax. You'll get it. But are there any questions so far? All right, here's the last two examples we're going to look at today, and then we're going to jump right back into example 5 when you walk in the door tomorrow. So get these down. All right, so in number 3, I'm going to just start lining up what I know and then see if it's given in the right order. So I can see that DF, oops, back it up, sorry. I can see that DF is going to match up with KL. So those are corresponding and congruent, good. And then I have angle D and I have angle K, so that's good. And then I have side DE and side KJ. So just go through in order. Do you have side, angle, side matching up with side, angle, side?
Yeah.
Yes. So this is a yes. Order matters in this. It has to be the angle in between the two sides. So you can see that the sides we know formed that angle that we know as well. Questions on number 3. Alright, let's look at number 4. So, LM is going to match with PR, right? And then I know angle M and angle P. And then it looks like these sides match up too, right? Everyone agree? Let's see what we know. So we know side angle side matches up with, do I know the angle in between the two sides here? No. So is this one going to work? No. And the reason is here they give us angle side side, ASS, no bad words in geometry, okay? So this one's a no. In order for these to work, we'd have to know that angle R and angle M were congruent. But P has nothing to do with it. It has to be the angle in the middle. So that's why that one's a no. What are your questions on this? All right, you all have your homework. You can go ahead and look at that. Okay, I want to look through especially the first section a little bit because we didn't do any in your notes like that. So everybody look at number 1. The directions say use the diagram at the right to name the included angles between the two given sides. So you have two